Oh, namaste. Um, Today our lecture is about the hypersonic similarity parameter, right? So we already know and we have experience, right, in the fluid dynamics in using the non-dimensional parameters, right? In many cases, we have non-dimensional parameters, and in most of the cases, we have some definite numbers. Say in the case of laminar flow, turbulent flow, transition flow, we call a number called the Reynolds number, right? And later, when the compressible flow exists, we call the Mach number, right? M infinity is a ratio between V infinity by A infinity, where A infinity is the velocity of sound, right? So like that it goes. So always we are very much interested in showing the non-dimensionalized number so that it can be used in anywhere, right? In any of the literature, right? And any of the research, right? So today our topic is hypersonic similarity parameter. Okay. So I acknowledge John D. Anderson's hypersonic and high temperature gas dynamics, right? So we will move to the hypersonic similarity parameter. Okay. So in the study of hypersonic flow over a slender body, say we have a slender body, we assume, right? Then the product of M1 and theta. So this M1 and theta is an important governing parameter. That M1 and theta is called as hypersonic similarity parameter, right? Where M1 is the free stream Mach number and theta is the flow deflection angle, right? We need not to think much, how this M1 theta came and all those things. As of now, I recommend you to remember that K is a hypersonic similarity parameter and it can be represented by the product of M1 into theta, right? So now our idea is to represent every uh, parameter, say pressure ratio, whatever theta beta m relation, density ratio, whatever it is, we would like to express in terms of the hypersonic similarity parameter, right? Okay, so let us move to the first point, right? So we already know that, say, uh, we know we have a theta beta m relation, right? Say, let us say theta beta m, right? So theta beta m relation. Now, the theta beta m relation, which is in the reduced form, right? So we know theta, which can be represented as um, 2 by beta, okay? Then it is multiplied by m1 square, m1 square beta square minus 1 by m1 square into gamma plus 1 plus 2. Okay, so this is the relation which we have got, right? So now we will reduce this equation and we can go to, now see, ultimately in this case we have already have the CP relation, right? You know very well that the CP we have calculated sometimes back, right? So we will represent the CP in terms of the hypersonic similarity parameter. So we start with this theta beta m, right? Now we can reduce this equation, right? I recommend you can also do this derivation in your notebook so that it will be easy for you, right? So now I would like to write that here we know m1 square beta square minus 1, that is equal to, right, theta beta by 2, right, into m1 square into gamma plus 1 plus 2, right? So finally we can reduce this equation, right? Say we can have a point that if um, okay, this also we can write something like m1 square into gamma plus 1 by 2 plus 1 into theta beta, theta beta. Okay. Now we have already an assumption that for hypersonic flow M1 is very much large, right, and finite, right? M1 is very much large, right, very much large and finite, a finite number, right? So if this is so, then the equation gamma plus 1, say this gamma plus 1 by 2, right, gamma plus 1 by 2 into m1 square is very much larger than 1. And and we know, okay, we will write here itself that uh, beta, say beta is also very small, right? Then we can write uh, see, when beta is very small, we can write m1 square beta square we have here, right? This component is large when compared to 1, right? Is very much large when compared to 1, when compared to 1. So if that is the case, now we have the equation m1 square, this equation become say m1 square, right, m1 square beta square minus 1, right, that is equal to gamma plus 1 by 2, right, and m1 square into theta beta, right? So this equation, right, because we know that this has no meaning, I mean very much greater than 1. So we write m1 square gamma plus 1 into theta beta, right? Now this equation, we can write it, it seems to be a kind of quadratic equation probably, right? So can we write something like, say, we can rearrange this equation, right? So let's rearrange this equation, and we can write beta by theta, right? Beta by theta square, right? That is equal to, or we can write something like, so we can write theta minus beta square minus gamma plus 1 by 2 into beta by theta, okay, minus 1 by m1 square theta square, that is equal to 0, right? So we have rearranged this equation. So now this becomes, in terms of beta by theta, right? And it seems to be a quadratic equation. Then we can write the beta by theta. We know beta by theta now. So beta by theta, that is equal to, so we know that minus b plus or minus root of b square minus 4ac by 2a. I hope you remember. So here it will become, say, by 2a. So I write this as gamma plus 1 by this 2 into 2 become 4 plus root of b square, that is gamma plus 1 by 2 uh, minus, right? So it will come like 1 by m1 square theta square. So we can write this equation, right? So beta by theta can be written as, right? Now you may ask, sir, what about the plus or minus, right here? So if it is minus here, right? So if it is plus or minus, if you consider, then the negative sign has no meaning, because when this becomes negative, say beta by theta becomes negative, it has no physical meaning, and hence we don't consider the negative sign, right? So we proceed. So now we have beta theta, right? So m1 square theta square. So m1 square theta square can be written as, say, m1 square theta square can be further written as k, which is necessarily the hypersonic similarity parameter, right? So now we can represent the pressure ratio, right? So let us write the pressure ratio. Say the pressure ratio P2 by P1, that is equal to 1 plus 2 gamma by gamma plus 1 into m1 square beta square minus 1. This we know, this equation, right? So let us say this equation. Now you know beta. What is beta, right? So beta by theta we know. Beta by theta, or yeah, here we know beta by theta is equal to gamma plus 1 by 4, right? Beta by theta is equal to gamma plus 1 by 4 uh, plus root of gamma plus 1 by 4 square plus 1 by m1 square theta square. So this is beta by theta. Now we want beta square, right? So I will take this as beta square, right, by theta square. Or we can write um, say directly the beta by theta, beta square, that is equal to, right? Okay, so let us write the beta by theta square, right? Say beta by theta square is equal to, we have this equation, right? Beta by theta square is equal to gamma plus 1 by 2 beta by theta. So you can write gamma plus 1 by 2 into beta by theta. So beta by theta is gamma plus 1 by 4 plus root of gamma plus 1 by 4 square plus 1 by m1 square theta square. m1 square theta square minus 1 by minus 1 by m1 square theta square. Okay. So this is the equation beta by theta square, right? Now let us write beta square, right? So let me write the equation beta square, right? So the beta square, that will become gamma plus 1 by 2 into gamma plus 1 by 4. See, please note that I am writing this equation gamma plus 1 by 2 into gamma plus 1 by 4 plus gamma plus 1 plus gamma plus 1 by 2 into root of gamma plus 1 by 4 square, right, plus 1 by m1 square theta square, right, 1 by m1 square theta square. Now I write beta square here, right? So we already know that there is by theta square. So I write this equation as theta square plus, not plus, it is minus, so minus 1 by m1 square. Actually, it will become m1 square theta square, but when it is multiplied by uh, m1 square, okay, yeah, okay. So this become m1 square, right? Now we want to substitute this beta square. So let us substitute this beta square in the equation P2 by P1, right? We know P2 by P1 is equal to, say, P2 by P1, that is equal to 1 plus 1 plus 2 gamma by gamma plus 1 into m1 square beta square minus 1. I think so, right? Yeah, correct. So now we can substitute the beta square that we have found it here, right? So we will substitute beta square here. Then our equation will become like, we can write the equation uh, P2 by P1, that is equal to 1 plus 2 gamma by gamma plus 1 multiplied by m1 square, this m1 square, right? Then beta square, that will become, say, I can write m1 square into gamma plus 1 square by this, 2 into 4 is equal to 8. So I will write 8, right? Plus the gamma plus 1 by 2 into the root of gamma plus 1 by 4 square, right? Plus 1 by m1 square theta square into the theta square, right? Into theta square, then this become minus 1 by m square, right? So I want you to reduce this equation. So I recommend you to reduce this equation, right? And okay, so please reduce this equation. So you can try to reduce this equation. So we can, we have a point that um, m1 square is, m1 is very much greater, right? So m1 square is very much greater when compared to 1, right? So the Mach number is very high Mach number, very high Mach number, right? And the angles are so small, and the small angle, that is the, so we can make some reduction, this can be neglected, and this um, right. Then the one also can be changed. Right. So now this equation should be, we have 2 gamma by gamma plus 1 m1 square into gamma plus 1 by 8, gamma plus 1 square by 8 plus gamma plus 1 by 2 into root of gamma plus 1 by 4 square plus 1 by m1 square theta square. Um, so we can write this equation now in a different way. Say this first term 2 gamma gamma plus 1. Let us write this equation. So we can write that say P2 by P1, that is equal to say gamma into gamma plus 1 by 4 into m1 square theta square. You remember this equation. So this equation becomes, so this equation is 2 here 4, and this gamma plus 1 become gamma plus 1. So gamma plus 1 by 4 into m1 square and theta square plus gamma into root of gamma plus 1 by 4. Here I think this whole square will come plus 1 by m1 square theta square, right? Which should be multiplied into m1 square theta square. So this become P2 by P1, correct? Now let us come back to our aim, right? Aim is to calculate the CP, the coefficient of pressure. We know that the coefficient of pressure becomes 2 by gamma m1 square, and here it will become say P2 by P1, right? So P2 by P1 minus 1, and finally we can write this equation as gamma into gamma plus 1 by 4 into what is that m1 square theta square. We can write a square plus gamma into this m1 square theta square become a square into root of gamma plus 1 square by 4 plus 1 by k square. This k square is m1 square theta square. But always please remember, we have an assumption here that m1 is very much greater, so we have neglected some parameters, and then um, the angle theta is so small, right? So now we will do one thing in this equation. Say we will have multiply and divide by theta square in this equation, right? So we can finally write the equation as Tp is equal to 2 theta square, right? 2 theta square by gamma k square. because this M1 square theta square will become k square into gamma plus 1 by 4 into k square plus gamma k square into root of gamma plus 1 square by 4 plus 1 by k square, right? Now, this equation is like, gamma k square, so gamma k square like that, and we can reduce this equation further, and we can write 2 theta square multiplied by so we can write this equation as gamma plus 1 divided by 4 plus root of gamma plus 1 by 4. So here it becomes square gamma plus 1 square by 4 plus 1 by k square. So this becomes the final equation of Cp, right? Final equation of Cp in terms of theta k and the gamma. Now, if I write something like Cp by theta square, then I can write it becomes function of gamma and k, right? So with the condition that the Mach number is very much greater than 1 and for a small flow deflection angle. Small flow deflection angle, right? So this is the final conclusion in our present discussion. The Cp is equal to Cp by theta square is in terms of uh, gamma and k, right? So it will be very useful in predicting the coefficient of pressure based on hypersonic similarity parameter um, for the hypersonic configurations, right? So the final equation will become like this, right? Cp is equal to 2 theta square into gamma plus 1 by 4 plus gamma plus 1 by 4 square plus 1 by k square. So we use this theta here and we can write everything in terms of k and gamma. I stop at this point, and this hypersonic parameter has a lot of application in the later stage. We will see that in the coming classes. Thank you very much.
Thank you, sir.
Thank you,
Yeah.
sir.